Morning, everybody. Today we're going to be talking about the last type of boundary we need to discuss, which is a transform boundary. Transform boundaries are boundaries that slide past one another. So in these types of boundaries, you would see these large lithospheric plates that carry either ocean and land, or ocean and continent, or continent and ocean, or land and land, whatever it is. But when they come together, or where they meet up, which is our boundary right there. This is not turning out as I hoped, but that's okay. So where they meet up here in the middle along the boundary, they are moving in opposite directions. So they are literally trying to move past one another. And I don't know if you could imagine it, and it's hard to explain like in video, but if you can imagine these two massive blocks of rock trying to get past one another. The stress between the two is building and building as they're trying to move. There's a rock trying to move past each other. And so the stress that builds up between these two plates that are locked pretty much in place because they're rock masses builds up. That stress that builds up is enormous. And so ultimately and eventually, when they do break free or gain footage and move past each other, this tends to create an area that's known as a fault. So the boundary itself, where they meet up and trying to slide past each other, is that fault. And of course, if you're imagining, just like I told you, these two giant, massive rock pieces trying to move past each other, and the stress that builds up. So ultimately, when they do move along the fault line in opposite directions, this creates massive earthquakes. Okay, and these are major earthquakes or massive earthquakes that are creating along this type of boundary. Our example for this is the San Andreas Fault. I don't know if you've heard of it, but most of you have heard of earthquakes in California, and this is that fault line or that boundary where two plates are moving or trying to move past each other, and when they do, they create those massive earthquakes. So this is where this type of earthquake can be found. So how do we measure earthquakes? We measure earthquakes with what's known as a seismograph. And we take that data that we gain from this machine, the seismograph, and we compare it to what's known as a Richter scale. A scientist named Richter came up with a scale to describe how, on a scale of 1 to 5, no, excuse me, I think it's 1 to 10, how the different types of earthquakes would impact land features. So, for example, not just the earthquake, what would be destroyed, how many houses and cities and things like that. So depending on the Richter scale or those numbers, it can tell you the strength, or another word for strength, and we've heard it before, is magnitude of the earthquake. So if you see here, it was a 7.0 or a 5.0 or 5.9. This is all based on the Richter scale. the data came in through the seismograph, and then we compared it to this scale to see how severe the earthquake was. So it measures the strength of the or describes the strength or the magnitude of the earthquake. What does that describes? Based on a scale. And it also describes damages to the surface that you might see. Okay, so also a nice point to note here is that in actuality, you may also have heard of tsunami. Let me turn my paper over. Here we go. I know pretty much everyone has heard of a tsunami. And in the American language, we refer to this as a tidal wave. So since earthquakes can occur along any boundary, they can occur along any boundary, but the most severe tend to be along the transform boundary. So when earthquakes occur along a transform boundary or along any other boundary, and they occur on the ocean floor, so on the ocean floor, when this happens, it sets a wave into motion, or not always, but can set a wave into motion that ends up being what we call a tsunami or a tidal wave. So remember, we talked about waves previously, ocean waves. Ocean waves are normally caused by wind, but this type of wave, the tidal wave or tsunami, is actually caused by earthquakes that occur along the ocean floor and along a boundary site on the ocean floor. So I just wanted to show you my model for this type of boundary. And here's my model. We have these two gigantic lithospheric plates. Remember, they are trying to move in opposing directions, and the stress that builds up between these two gigantic lithospheric rock plates is extensive, and so it builds, and finally they break free. And so if this was our roadway, for example, we note that, okay, so it's totally displaced because the boundaries are moving past one another. So I hope this helps you out. Transform is another word for change. Will it change your surface? Absolutely. These boundaries do change the surface, and I will post some quick clips of earthquakes that have occurred and what the surface looks like. All right, guys, I hope you enjoyed the video. Talk to you next time. Bye.